Very good morning, class. In the previous video, we have calculated the capacitance of a parallel plate capacitor. That was epsilon naught A upon D. If the dielectric slab is placed, if the dielectric material is filled between the plate, then it was K epsilon naught A upon D. Right? That was, I'm writing here, that was C equals to K epsilon naught A upon D, right? Then we have discussed what are the factors which affect the value of capacitance of PPC, right? Now in today's video we will discuss if instead of filling the dielectric between the plate, what if we place a slab of some thickness between the plate. That means the space between the plates is not entirely filled with the dielectric, but it have a slab of thickness T between the plates, right? So the today's topic of the video is the capacitance of a parallel plate capacitor with a dielectric slab between the plates. Okay, capacitance of PPC, that is parallel plate capacitor with dielectric slab between the plates. Okay. Now let's first make the diagram. Now in this case we have, let's say this is the capacitor, okay, having area, overlapping area A, and the distance between the plates is basically D. Now instead of filling the dielectric material completely between the plates, we have inserted a slab of dielectric of thickness T. Okay, now you can see in the diagram we have a slab of dielectric of thickness T. Alright, and let's say the dielectric constant of this material is K. The charge on the plates of the capacitor, let's say this is positive charge plus Q, right? And due to induction on this side of this dielectric, the negative charge will appear. So it will be negative charge minus so here it will be negative charge, and with induction on this side, this will be positive charge, and here on this plate it will be negative charge. So we have mentioned the charges induces on the plate as well as on the dielectric. Now to find the capacitance, if you remember in the very first video I told you there are some steps. What are the steps? Steps was, first we have to calculate the potential due to the system, and then we have to just apply formula Q equals to CV, then we can find the value of capacitance here. Now to find the value of potential, first we have to find the value of electrical field, because we don't have the direct formula to find the value of the potential due to these parallel plates, but yes, we have a formula for electrical field. Now in this case you can see that due to charge distribution we have two electrical fields. First, in this portion you can see here where the slab is not present. Let's say here in this portion we have air or vacuum. So the electrical field exists between this portion, let's say it is E0, right? and between the plates, between the dielectric, let's say it is E dash. The electrical field is E dash. Now, why we are representing two different electrical fields? Because you can see that the direction of electrical field is from the positive charge to the negative charge. So outside this slab, it is from plate. Let's say this plate is P1 and this plate is P2. So you can see that the electrical field is from P1 to P2. Right? It is going from P1 to P2. So this is the direction of electrical field E naught. But you can see in the slab, the positive charge is near the P2 plate and the negative is near the P1 plate. So the dielectrical field inside the dielectric will be opposite. But it is not E dash, it is EI. Why EI? I means inside. So this will be directed here in the opposite side of the external electrical field E naught. What will be the values of these field? E naught, that is the electrical field present in the between the plates where there is no electrical slab, there is a vacuum or air. So E naught will be sigma upon epsilon naught. You know this formula, we have done this formula in the application of Gauss theorem, right? Sigma, you know that sigma is surface charge density, which can be written as Q upon A epsilon naught, right? So E naught becomes Q upon A epsilon naught. Let's say this is equation number 1. Now we have to calculate the electrical field inside the plate, inside the dielectric, EI. So what will be EI? Okay, now remember the formula. What was the formula? If the charge is present in some medium, the formula becomes 1 upon 4 pi epsilon naught K Q upon R square, right? Remember? That is, whenever we find the electrical field or electrical force in some medium, it reduces by the factor K. So similarly, in this case, the internal electrical field inside the slab will be E naught divided by K, right? And E naught is this. So this will be Q upon K A epsilon naught. This is equation number 2. So you can see that in we have already calculated the value of electrical fields between the plates. First, where the slab does not exist, and second, where the slab existed. Now, to calculate the potential, we know the relation between the electrical field and the potential. E equals to V upon D, right? Electrical field is equals to potential divided by distance between the plates. Now, in this case, we have two electrical fields, E naught and EI. That means these two electrical field will provide two different potential, right? So, what will be the total potential in this case? You can take screenshot, I am rubbing it. Okay, so the value of potential is V equals to E into D, distance, right? Now here we have two electrical fields. First E naught, and E naught is existed in how much space? The total distance is D, in which T is the thickness of the slab. So how much area is left? How much distance is left? D minus T. That means between the plates, the length of the vacuum or air is nothing but D minus T, right? That means the electrical field in the vacuum is only for distance D minus T. Let's see once again. The total distance is D, right? In which this thickness is T. So the distance left for the vacuum is D minus T. So the total electrical field potential will be E naught into D minus T. Is it fine? And plus EI, now in which the distance in which the electrical field EI exists is, you can see here directly, T. So EI into T. Now we have to put the values of E naught and EI and solve it. So when you put the values, V equals to, what was the E naught? E naught was Q upon A epsilon naught, it is D minus T, and plus that was Q upon K A epsilon naught into T. Okay, we know that V is, and we know that what is the next step? Next step is apply the formula V equals to Q by C. So V is nothing but Q by C. Apply the value of potential here. You will give, this will be equals to Q by C. Alright. Now you can see in this expression, if you take Q common, they will be cancelled out. So we get the value of 1 by C. So 1 by C is equals to D minus T upon A epsilon naught plus T upon K A epsilon naught. Okay. Now we have to take the LCM and solve it further. After taking LCM, you will get C equals to epsilon naught A upon D minus T plus T upon K. So this is the value of capacitance of the parallel plate capacitor when a slab of dielectric has been placed between the plates. Now let's talk about some special cases in this derivation. Formula is C equals to epsilon naught A upon D minus T plus T upon K, right, where T is the thickness of the dielectric. Now what if the thickness T becomes equals to D? What does it mean? Thickness T will equals to become D when the dielectric is completely filled inside the plates. So if we are talking about the A case, when T is equals to D. So when T is equals to D, this term will become 0. This term will become 0, and plus this will, T is equals to D. So D upon K. So this will become epsilon naught A, K will be upward, upon D. Right? As you can see that this is the formula of electrical, it is the formula of capacitance of a PPC when it is completely filled with some dielectric. So that means this is satisfying the case, right? Third case, if the slab of metal is being inserted between the plates, then what will happen? Let's see. So see, we are doing the B case when a metal plate is inserted between the plates. Now formula will remain same, but the dielectric of metal, the value of dielectric of metals is equals to infinity, right? K for metal is equals to infinity. Always remember this, K for metal is always equals to infinity. So if you apply the this value here, what you will get? C equals to epsilon naught A upon D minus T upon K, T upon infinity, because the value of K is infinity. And you know that if anything divided by infinity will be give you 0. So this term will become 0, that means this will be the formula for C in the case of when the metal is inserted between the plates, right? Now what if we have so many plates of different thickness and different dielectric medium, dielectric constant has been inserted between the plates. What will be the new dielectric capacitance? Let's see. Now instead of one plate, we have inserted so many plates, n number of plates, like this. Like this. This is of thickness T1, T2, T3 up to Tn, having constant K1, K2, K3 up to Kn. No problem, formula will remain same. There is a slight change in the formula. It becomes C equals to epsilon naught A upon, formula was D minus T, but now we have so many T's. This will become D minus T1 plus T2 plus T3 up to Tn, right, and plus T upon K, plus T1 upon K1 plus T2 upon K2 plus T3 upon K3 plus Tn upon Kn. So in this case the formula will become this. So this is how you can calculate the capacitance in different cases, right? This derivation is very important from the point of view of exams, and numericals also come from this topic. In the next video, I will discuss the combination of capacitance, which is very important topic from this chapter, because at least 1 to 2 questions will definitely come in your exam from the topic combination of capacitance. So for now, thank you very much.